from the University of Bologna. Okay. Good afternoon. My name is Rodrigo Campos. I'm a PhD student from the University of Bologna, and I will present the work called Preliminary Developments for a Machine Learning Dose-Scaling and Prediction System, training on long-term numerical simulations of sea level. So the outline of this presentation, the first place an introduction, then the numerical model description, the model validation, and then first preliminary statistical downscaling for the sea level, and finally the conclusions and future steps. So starting with introduction, we have that urban settlements near to the coastal environments are particularly exposed to the ocean and cryosphere changes, just as the sea level and extreme sea levels. So these changes in the sea level, this rise in the sea level, induces a permanent loss of land without various types of impacts, which are most evident in urban and densely populated areas. So the high-resolution sea level prediction systems have become fundamental tools to take preventive measures in the face of the extreme events of the sea level, mainly in the most vulnerable coastal locations. And in this line, tools such as machine learning and artificial intelligence are at the forefront of the development of this sector of the forecast for preventions. And mainly because these tools can reduce the computational time needed to reproduce the results of highly costly, high resolution models with high cost resources of time and computation. So in this slide, we can see we have 5 different works of different authors, which in the works, the authors use different methods for statistical downscaling of the sea level, using statistical and machine learning methods for different variables of interest, but in different scales, global and local. But one thing that we found is that in none of these works the authors are using high resolution dynamic downscaling results to train the statistical tools to make the downscaling. So in this way, to developing a data-driven system for the sea level downscaling by using a very high resolution circulation model, the output of this high resolution circulation model to train a machine learning framework. So for this, we carry out a long-term simulation of the sea level in the Northern Adriatic using the Source-Scheiffen model. So in this presentation, first I will start with the development of the high-resolution models. As I said, it's in the Northern Adriatic. And for the validation, we are using 4 points. One, the CNR platform, one inside the Punta de la Salud, inside the Venice Lagoon, another one in Grado, and finally one in Trieste in Molo Sartorio. And after the validation, we start with a preliminary assessment of the potentiality of statistical downscaling by training and testing simple linear regressions between the low resolution databases, which will be the predictors, and the output of our high resolution circulation model, which will be the predictant. So related to the numerical model description, in this slide, we can see on the left side the grid that we built to carry out the simulations with an offshore resolution of 3 kilometers and an nearshore resolution of 50 meters. And on the right side, we can see the bathymetry covering all the area of interest, which comes from EMODNet. As input sources, we are using, for the atmospherics, we're using wind velocity and mean sea level pressure from ERA 5. And from the ocean, we are using the sea level detailed from Copernicus Mediterranean sea physics reanalysis. Sorry, we're using this database because it's a long-term database. And since we want to simulate the total sea level, we are also including tides from the FES 2014 model. So we are putting the sea level detailed and the tides together in the boundary condition to simulate the total sea level. Now going to the model validation, and this slide, well, before we did any comparison, we apply a trend of the sea level series, because in this way, the extreme sea levels from different years are made climatically homogeneous and we can easily compare them. So the time series that we're watching, it's for the 4 locations that I mentioned before. In the upper panel of each figure is the long-term series for the 34 years. And in the lower panel, sorry, is a monthly series. In the case of Punta de la Salute, Grado, and Molo Sartorio, is for November 2019 for a big flood event in Venice. And for the CR platform is of November 2013, mainly because of the data availability. So one thing that we're watching in the results, it's that for the mean conditions, the model is, let's say, obtaining an accurate representation of the sea level, which can be seen on the results from the CR platform and a big part of the other series. But if we put our attention in the main extreme events, for example, close to the 12th of November of 2019, we can see there's a difference in the extreme events between the tidal gauge and our simulations. And well, now we know from Ivan's presentation that there's a big part of this, or important contribution from the waves, that can maybe resolve a little bit of this difference. And since I'm not including the waves into the boundary conditions, this is maybe the difference, or maybe a reason for these differences.
No, is this a continuous integration?
How? Yeah, it's continuous. Yeah. And this is density scatter plots, just to show that let's say how good we are representing the sea level. So, well, as I said, we consider that we have an accurate representation of sea level with correlations between 90 and 94%, root mean square error about 8 and 12 centimeters. And as I said, the main difference are on the extreme events. So after we did this validation and any other processes, we moved to the preliminary statistical downscaling for the sea level. And well, this process, we starting applying this statistical downscaling in Punta de la Salute and Molo Sartorio. So what we're watching in this slide, on the left side is the complete area for the Copernicus reanalysis, the sea level divided, and just for a random type, just to explain that we are considering to choose the predictors. We're choosing an area. Yeah. Okay. So yeah, we have in this this left side the complete area, as I said, and we have this point of reference of Punta de la Salute and Trieste, and we're considering this area to select the predictors because we found this work of Tausia et al. Of this year, 2023, that since we are using multilinear regressions, these authors found that if we choose an area for the predictors, the multilinear regression performs best with regional predictors. So for a training period for the statistical downscaling, the linear regressions, we're using the 70% of the data. And this series shows just the last year, just to have a clear idea of what are we using. So for predictant, we are using the simulations from SciFem. And for predictors, we are using the sea level divided, the tide prediction, and the mean sea level pressure. And for the validation period, we're using the rest of the 30% of the data. And we are obtaining that with this statistical downscaling tool, we are obtaining skills that are comparable with the one that we obtain with the numerical simulations with SciFem. And which is something really important, considering also that the time that is needed just to carry out this statistical downscaling, which is quite really fast, it's just a few minutes. And this is what are we looking for. So for conclusions and next steps, as main conclusions, we have that the numerical simulation shows an accurate representation of the sea level. But as I mentioned, there's an underestimation of the extreme events. And also with the statistical downscaling, we found that simple and fast statistical downscaling techniques can result in a fast downscaling system with skills which are comparable with the ones of the high resolution numerical model. So for next steps, we will try to improve the representation of extreme events in the high resolution model, and also identify the best low resolution mid-ocean predictors for the high resolution sea levels, and also the application of different methods for the statistical downscaling. And finally, make an operational framework with a forecast, which is like the final objective of the research in the program. These are the reference. Thank you very much.
Thank you. Is there any question? Two.
Thank you. Very nice presentation. You mentioned about the importance of waves, which were not considered, but I didn't understand. Are you using barotropic two-dimensional model or fully baroclinic one?
No, barotropic.
Because what is the effect of baroclinicity on the sea level change?
Yeah, because before start with any long-term simulation, we did some cases of 1 or 2 months, and we found that there was no big differences between the baroclinic and barotropic. In this case, I'm not making a general specification. So this is why we're using the barotropic. That's the explanation.
The underestimation could be due also to the coarser atmospheric force in your case, since you use ERA 5, and the ERA 5 has this underestimation of extreme also for tropical cyclones. So in overall the world ocean, so for the extreme hours, this underestimation, so could be one of the main reasons in your case.
Mm-hmm.
Thank you. Very nice presentation. Just a curiosity, which is the frequency of output of Shifam that you are using? Is daily or hourly?
Hourly.
Hourly.
Mm-hmm.
And another question is, you are testing using the 30% of your data. Is that one-shot prediction or is a rollout prediction?
I'm training with 70% that you mentioned.
Yeah, and you're testing with 30%.
Yes.
Is that one-shot prediction or is a rollout prediction? I mean, you are predicting a state of the model, in your case, sea level anomaly, and then the prediction is the input for the new prediction. Or it's just one-shot prediction? Or one shot?
Yeah.
Okay. Thank you.
I have the same curiosity that for the training data, you showed a point, your time series, 70% time series is just for one point?
No. It's a reference point to choose the area. Like, let's say the point and the delta latitude and delta longitude. It's just to select the area.
So it's a particular area. So then.
Yeah, the area that I'm marking the black lines. Yeah, the point is just a reference point before in front of the stations, and just to select the area.
Okay.
Yeah. Do you plan to do sensitivity experiments on the training period, the training length period, and area?
Yeah, actually, until now we don't have let's say a criteria to select the area, and we also need to test the size of the area, and also a principal component analysis, more deeply analysis of the to select the predictors. This is like really recent, so that's something that we need to work.
Thank you very much. Thank you. So next presentation is Dr. Jetani Saha. Online. Okay. Do you hear us?
Yes. Am I audible to you?
Yes, you are. You can share your screen, please, Gitali.
Yeah, sure.
Can you click share screen, please?
Yeah, Just a minute.
It's it's the bottom central button is written share screen. You have to click it and select the screen.
Yes, yes.
And then share. We don't see your presentation up now.
True.
Yeah, now we see your screen.
Yeah. You must be looking at the first slide, I believe.
No, not yet. Just a moment. We still see the list of files. Did you open?
Yeah, I did open it.
No, then it's not working.
Just a minute. Let me start again. I believe this should work now. You now see the
Yes.
list.
Now it works.
Yeah. I'm going into presentation mode.
Yes, please.
If it permits me. Yeah, this is the presentation mode. Okay. Good evening, everyone. I'll be discussing the prediction of SSTA dataset using machine learning techniques. To begin with, these are the details of the different aspects that I'll be covering throughout my entire presentation. The first part is the introduction. So we are aware that sea surface temperature and sea surface temperature anomaly are considered to be the most significant physical oceanographic parameters related to biological, chemical, and physiological changes. And the reason this parameter is so widely studied is because the ocean itself has got a very large extent. So there is a temporal variation as well as there is a spatial variation. And that is the reason data learning techniques, data-oriented techniques are becoming more popular. So what I have done in my task is that I have collected data from some specific locations which are identified to be major contributors, and with the help of some machine learning techniques, to be more precise, I have used nonlinear autoregressive techniques. I have tried to predict the value of the SST anomaly. These are basic introductory slides about the significance of SST and SSTA and how it affects our marine ecosystem. This is a picture, an image of what do we understand by SST and what do we understand by SSTA. The readings are taken on as on 10th May, that is yesterday's reading. And they are taken from the website tropicaltidbits.com. The details of the images, if taken from any other website, they are given in the slide itself. So what we have here is that when we talk about sea surface temperature, we have got the value of the temperature at those specific locations. As you can see here, some pixels are shown and the value at that location is recorded. If you try to see the image on the right hand side, we have the anomaly, that is the SST anomaly. That means the deviation from the mean value. Now, in most of the cases, the mean value or the average value is calculated based on previous 10 years benchmark or 15 years benchmark. And based on that, whatever is the present reading, they are a difference value of it is taken. And that becomes the anomaly. So the scale, if you see on the right-hand side of each image, gives us the value of how much variation is there on each map. So over here, the variation is from 2 to 32 degrees centigrade. And in this case, it is -5 to +5 because it is a difference value, difference with respect to the mean value. Okay, coming to the portion of study, which portion that I have studied about and where from the data has been taken. So this are identified as the NINO 1+2 portion. That is this one. I believe I can have the choice of pointer. Yeah, so this is NINO 1+2, NINO 3, and NINO 3+4. NINO 4 is the one which is having least variation. We'll see as we go through the next slides on the left-hand side of South America, as evident from this global map. Now, the locations, their actual geometric locations in the sense geographical north-south, east-west location, and the characteristics and why it is chosen, what is the reason for choosing this specific reasons and why not choosing something else. Right? So NINO 1+2, as I said, it shows largest variation of NINO SST. NINO 3 is something which has been widely covered, widely studied. NINO 3.4 has got a 5-month running mean where SST is larger than plus 0.4 degrees centigrade are recorded for 6 months, and NINO 4 is the least variance one. Right. Similarly, we have ONI. ONI is again one more index used widely in our machine learning techniques for the evaluations of this various phenomena. This is the El Nino phenomena, which is generally known to all of us. So I'm not going into much details about it. I'll speak about the data set next. So what I have done is that I have collected the data from Dr. D. Cook set that he had. It contains 12 attributes, out of which some of them were missing. So I choose those values which were more present, not much of missing values, because with missing values, then again, we have to have an algorithm to place the values, right? So I have chosen 5 attributes out of this, and with the help of them, I have tried to judge the SSTA with the help of my prediction algorithms. Now we have the subsurface temperatures down to 500 meters depth, surface winds, sea surface temperature, air temperature, and relative humidity. Present data set is located for this specific regions, and slightly larger than 10 years of data set is available, which is having a numerical value of 178,080 instances. Now, in machine learning techniques, we generally want to avoid overfitting. Overfitting means when we train our system to a larger extent, it tends to give us incorrect information. So in order to avoid overfitting, we always insist upon having the training data set separate from the testing data set. So in order to make sure that this is taken care of, what I did is that I initially bifurcated my entire data into 2 slots. The training was from 10 May 1985 to 10 May 1995. That is a 10-year data. That is my training data. And 11/5/1995 to 27/1995 is my independent test data set. Now, there could be a query as to why I have selected this range for my training data. The reason being, many El Nino and La Nina events have happened in this phase, and specifically in the regions that I have classified right now. That is the reason that region is selected, and that is also the reason this date durations are selected. Of course, the added advantage was that this was available in the given data set. So I could, it became, conducive parameter for me to go with. Coming to the networks that I have used, the algorithms that I have used a nonlinear autoregressive method, which is composed of a time series, which we can feed to a feed-forward neural network, and it has backpropagation of error. So what I'm doing is that I'm feeding the series, I'm finding out the next value, and I can backpropagate the error. Similarly, I also have a choice of giving 2 or more time series into input, and I can judge the next value of the SST parameter, and then I can evaluate the anomaly of it. Now, if you look into the last slide, it is only the SST value itself which goes as input. And based on that, I predict the value of SST for the next duration. In this slide, I have taken the help of SST time series as well as wind, relative humidity, zonal winds, meridional winds to predict again the value of SST. So in the last one, it is only with the help of SST. In the present one, it is SST plus additive time series, which is helping me in giving a better prediction. So this is the actual core of my entire study. This is, we say, the neuron based representation of our entire set. We have got our input and a set of additional inputs that can help me in giving the present decision, and I'm calling it D, where D is the number of delay neurons and H is the number of hidden neurons that will help this network to predict the next value. This is different from the last case. As you can see that there is a loop which is taking the value from the output end to the input side. So we have got a feedback. Right? So this becomes a closed loop configuration. If you look into the last one, it is an open loop configuration. The second one is a closed loop configuration. This has been investigated in terms of single step prediction as well as multiple step prediction. Multiple step for that is for 7 days at a time. So 7 values, one for each day. This is what is known as NARX. It is a nonlinear autoregressive with X stands for exogenous input. So as I mentioned, we have taken wind, zonal and meridional winds giving the best possible results in order to predict the value of sea surface temperature. Presently, it is the open loop configuration with additive time series, and the next one is a closed loop configuration with additive time series. This is the method of workflow. 10 years of SST data is given to the neural network as the training data set. Testing data set, total 70 days, 1 week each at a time, 10 steps are taken, 10 iterations are compiled. So I've been using a certain number of legends where SSTA stands for the calculated anomaly by taking the difference of the mean from the actual. That is simple mathematical SSTA. Then we have SSTA NAR, that is SSTA calculated using the SST series only. Next, I have SSTA air temperature. That means I have calculated SSTA using the air temperature data time series as an additional input or an exogenous input. Similarly, SSTA Z for zonal winds supportive as an exogenous input, and M for meridional winds supportive as the exogenous inputs. And these are my results. So as you can make out, there are at an average starting from here, we have approximately 70 steps, 70 timestamps. This is the blue one is the mathematically calculated anomaly, SST anomaly. Then the other ones are the SSTA calculated with the help of no exogenous input, air temperature as a supportive time series, zonal winds as a supportive time series, and meridional winds as a supportive time series. And it is found that with meridional winds, we get the most closest approximation. Okay, this brings me to an end of this slide. I'll keep this in case someone has any queries or someone wants to ask something. We are over to the question and answer session.
Thank you very much.
Thank you very much.
I think I can come back to the, yeah, I can come back to the session.
Any question?
Hi, thank you very much. Very interesting. I mean, what is the timing up to 69 there? What is the unit?
The x-axis happens to be single day value.
Okay, so it is a 70-day forecast.
Yeah, 70-day forecast, 7 days at a time, 1 week at a time. So multi-step forecast.
Okay, so it's 1 week forecast.
1 week forecast and 10 such iterations, making it 7 into 10, 70.
So how good is this forecast with respect to, for example, the available numerical model forecasts, operational oceanographic models?
Yeah.
What is
So
your...
presently, what I have done is that I have taken this data for a specific location only. If I want to compare it with the numerically existing forecast, then I have to take it at various locations. And at various locations, I have to take the data at various locations. And the constraint is that for all locations, this data is not completely available. Some data are missing. And the reason for selecting this time period is that it is a vital time period where many El Nino and La Nina changes have occurred. So I had to go with this time period. Supposing I take some recent time period, probably I'll be able to judge that.
I have another question. Is there any reason why this method should not work in a coastal area for SST that you can imagine?
My study was more to find out which time series would help me in finding SST more precisely. This was available to me uh, at, at the deeper ocean levels, and such data was not available to me at the coastal regions. So maybe if I get the data, I can experiment and try to find out. Without experimenting, it is difficult for me to answer that. It could probably work, maybe with some variation in the algorithm. By optimizing the algorithm, it should work. Theoretically, I am yet to confirm it with the help of data.
Thank you very much. So now I ask you the last effort. I'd say we are 15 minutes late, so we try to do now half an hour discussion, and then we stop. It was a very intense day, but I think we need and we deserve to highlight a bit the challenges, the gap, and the way forward on the two main aspects we have touched upon today. So I'd say the observing system and the forecasting system for short term forecast. So I would say the key question is which are the gaps, and in your opinion, I mean, you can also be practically, you can also give practical example, maybe inspired by today's presentation. So you can also be generic and more strategic opinion. From my perspective, we have seen very for the observing system, we have seen very interesting example of low-cost, innovative, and portable observing system. Say to integrate them with more classical coastal observing system. We haven't seen a lot of satellite new data. We haven't seen about drones, but we have seen some innovation today. So does anybody wants to comment on if this let's say deployable relocatable observing system we believe is one of the priority? maybe also from the modeling point of view. I mean, we have some modelers that has used start to use this data. I mean, is the quality enough? What is the advantage of this community observing system for the modeling? Okay. Online, I need help. No. Christina? Oh, is it? Huh? Ah, no, Christina Forbes is, yeah, it's from US. Okay, Christina, you want to talk? Do you hear me?
Yeah, can you hear me? Can you hear me?
Oh, we cannot hear you.
Can you hear me now? Can you hear me?
You have a problem with the mic. The voice come very.
I don't know.
Do you have headphones?
No. Sorry.
No, it's not working. It's broken. The voice comes very strange.
Okay.
You try to get out and get in again.
Okay, I will.
No, I mean, then I do the different way. Oh, Aldo, because otherwise I have a question for Ivan.
Just to break the ice, I mean, just a general comment, sharing this comment with you. This is my impression. From the presentations today, of course, there is a lot of science going on, lots of very good efforts. But on the other hand, my impression is that there is a lot of individualized work, a lot of effort being done separately. And can we plan to improve on this? Namely, can we plan to do things more together so that we avoid too many people having to reinvent the wheel and doing similar but different things, but doing them together? So this is my challenge question to you on whether you feel the same impression and whether we can find out a means of exploiting opportunities in a different way for the future.
Yeah, I agree. And I wonder if even just creating like a matrix, a table with, for example, just starting with all of the different models that have been discussed today and all the different applications, you know, where they work, what the resolution is, you know, what the limitations are, and just a very, you know, high level table so that anyone who wants to work on something specific can look at this this table and see, you know, they don't have to go through the understanding by themselves for the first, I don't know, 6 months, year, and they just go straight to that table, and it's anyone within, you know, this Coast Predict community that will benefit.
Yeah,
At least it will help me, that's for sure.
Yes, I mean, this is why practically to answer Aldo, we did Coast Predict because in fact, we realized the community, the coastal community is fragmented. You know, as you know, you were a major contributor. We could get together at the level of a regional, and we did, and we came out with a good result. But about coastal is difficult. And so we are envisaging to do, tomorrow you will see, to do a global coast experiment where we try to get together, but in different areas, because to get across is too early. First, you have to have several groups working together, maybe, in an area of interest. Several, not, I wouldn't say only the people living there, maybe also from other places, working on an area. So focus the area and then use the different tools, have the table with the different models, collected through these different test sites. We will call them eventually. And then at that point, after we try to have at least in this test area to work together, then we can also get together at the global level and then bring the experience to the next step. Yeah, I agree. The fragmentation is a major issue. And one way to overcome is with the global coast.
So I just, following on from Delphine's comment as well, I wanted to understand a little bit better what the Mercator Ocean Decade Coordination Center. So that's been doing that kind of thing, but for different regions. So it's been, there's different subcomponents of the DCC which cover different regions, right? So we're leading the African one, and they've been trying to establish what modeling is being done in Africa and feed in, and then there's one for the Indian Ocean, and on and on and on. And I think that's covered ocean modeling and coastal, but I'm not quite sure. But so I think your idea is great, but I'm worried at the overlap of constantly asking people to create a thing to understand.
Yeah.
We need to do it, but how's best now to get the information from the DCCs? Is it going to cover what Coast Predict is doing?
I think Juliette is right. We will benefit from what the DCC on ocean prediction is doing, but and as Nadia was explaining, Coast Predict will start from deciding how to and then selecting the sites. And then, of course, within that sites, we will interview, let's say, query to the experts of the area that are here, that are online, that are joining us. We will identify all the observing system and the modeling capability, the challenges, and so on. And there, of course, we will have all the information and also across the sites, this information will be exchangeable because the same format and so on. So somehow it's true that we will benefit from what Mercator is doing in ocean prediction because some people are already aware, but then they will be also engaged at the site.
It's a bit moving on though, so if anyone wants to add. But I've got the microphone. So. No, do you not want to carry on with that conversation?
Yeah, I want to add something to that. I'm Felix from Deltaris, presenting tomorrow, so then you will know more. I'm really inspired and touched by all the organizational steps we're taking to cooperate. But as I'm envisioning to get to the science we need for the ocean we want, I think there's also like an emotional step that we're taking in actually listening to each other. So what has touched me today is that people from all over the world have shared their challenges, their steps forward. And apart from all the information that we are conveying, I think it also really brings my picture of what people in other areas of the world need. And I think if we take more steps in putting the heart in and listening to each other, we get a better and better view upon how to help each other and how to reach each other. And that's, I think, on top of the organizational steps that we're taking. So that's, yeah, I think really makes me smile and happy that we're sharing that way.
So I wanted to ask as well, and it goes back to what Nadia said this morning when you said you were...
Can you tell your name before talking, also for the notes, because otherwise...
Sorry.
No, it's okay.
Juliette. So when Nadia was saying about engaging with the IOC and the WMO, and thinking about it now, to what extent are we engaging with navies who often do a lot of observations or have vessels, and to what extent, so for me, listening to about the relocatable models and the observations, I haven't really seen anything about wind measurements and the importance of those in the models and also in the coastal observing systems. And so to what extent are we engaging with the local Met services to try and understand how, we can work with those.
No, actually, what I wanted to say from what we have seen today is that both the integration observing system and also coastal model system, they're mature enough by themselves to replicate the coastal oceans. This is what we have seen in several replications, in several presentations. But since it has been mentioned relocatability, of course, many groups are trying to do that, which is not so trivial because the different areas have different physical characteristics and there are many gaps that we have to consider. What I have not heard today when it comes to these relocated models is the use of the hybrid approach, in which the dynamical models will be used together with artificial intelligence toward the relocatable modeling approach. Another big issue when it comes to transferring from one system to another in respect of the global cost, of course, is the lack of observations. Although there are quite advanced observational systems, there are many gaps. We were discussing that in the breaks. When it comes to biogeochemical parameters, to the nature-based solutions, there are very, very few data. Those data are very sparse. Even the units are not clear. Even if it comes to the physical models, go in the hindcast and in the past, the data are also sparse. And we have seen also many presentations for the forecast in the future. And then how can we do the projection if we don't know the history? And another problem is that you mentioned we made this table with inventory of many models, many data. There have been many publications on that. For example, for the North Sea only basin, there was a recent publication that ended up with, I don't remember, 30 or 40 different models. But at the end, what are the end user needs? They don't need information with complex, what is the resolution, the parameters. So what we need also to discuss is what is the best way to transform this kind of big information that integrated system, coastal systems are producing in terms to be used by the intermediate and end users.
Christina, try now.
Okay, can you hear me now? I borrow this.
There is some problem with your mic.
Can you chat? You can chat and someone can read what you want to ask.
Hello?
Your voice come broken.
Okay.
Christina,
Okay,
can you
your computer?
Can you message? Can you use the message window?
We stop.
Hello?
Tina, your voice is broken. I'm sorry. Just type a message because we don't hear.
Make a comment. You know, when we started to do forecasting in the coastal areas, in the ocean, we were trying to find the best model. Then we understand that there is no best model, that instead we have to use, I just wanted to repeat because maybe young people did not yet go through that experience. But what we understood is that we have to sample the uncertainty in the models. So we have to do ensemble. So it is very useful to know how many models you have, or you can, because you're gonna use them. That's no, I'm sorry. No, it's not too bad, because I mean, she's really a. So I want to go to another point. So we said that there is fragmentation. So maybe if we do organize the global cost experiment in the right way with a digital infrastructure that helps to share what also Fugro is trying to develop, sharing the data, the tools, and so on, we will be able to do. But the other thing that we have missing, that Joanna just reminded us, is the dialogue with the users, right? And so again, we cannot do it at the very generic level, that one. We have to undertake a process of engagement with users in the different areas. We can't do it general. So we can do general, the list of models. We can do general, the observing system. But then when we arrive, to test our hypothesis, we have to do it in areas.
And if I can add, the area should be selected to cover a variety of coastal zone, challenges or differences, estuary to marine protected area, urban ocean, so that then at the end, when we generalize, we are covering most of the challenges.
Yeah, if I can just add one final comment about this table that I was mentioning. I know that there are many tables and publications that already have this list. What I was actually referring to is more what has been done in the last months, that we have seen today that's really pushing on the boundaries of machine learning, downscaling, and these things that it's not something that's been around for decades, and so we're it's so innovative that it's like new from today, and having a way to understand what the limitations are, like what was mentioned about, okay, but here you don't have waves or wind, or and what are the implications of those tiny differences between each of these these new modeling techniques that we've seen today.
Yeah. I think
Just
we
kind of adding on lists. Yeah. Yes, exactly. A living table. Yeah. Yes, exactly. Yeah.
Well,
yes.
if
Yeah. It has to be a living table.
If I can comment, I think Dolphin is interpreting or representing a user request. So the user, as an intermediate user from private sector, is saying that he wants to be able to, drive or be driven in the different news and updated that we are doing. That's an important metadata information that we need to grab, and then and it's also useful to present our products to the users. It's
yes,
very
and exactly,
it's much more than a table.
Yeah, exactly. And I also think that, so for example, we're going to be going to Fiji, we're going to be speaking to, all of these, the final end users, right? So it's going to be policymakers, decision makers, and they will let us know what they need to see, what data they're going to be using, what is important for them in their regions. We then need to come to some database, some table, something that we can say, okay, for this particular case, let's look at the check marks on this this matrix, and we know that that is the best combination of all of what's being done in the Coast Predict community. Yeah. Well,
DCC on ocean predictions, because I think that everything here we have said, even though some people still use barotropic models, is because we have the global and the regional availability of at least first guesses, let's say. Not really first guess, we call it background, but only because we have this, so the first step, right? So I would like to get in a discussion with DCC Ocean Prediction after we have selected our areas where we understand how to make available what is openly free and in that area from the global, because we have the Chinese system, we have seen it, we have the European system and the US system. And I want to mention also the Navy, because I started with the Navy to do the forecast, because clearly they are the most interested and most open-minded people in that sector. And I have to say that they should be one of the users, intermediate, not final, because they have another final one, but intermediate. And I think this is, after so many years, it is their appropriate location, meaning that in addition to, like most of us, we are producers, like they are, of data, models, and so on, and we are also intermediate users. But then above that, I think that it should be left to open and initiatives that go. We can't go farther than that. We get, personally, I think it is very difficult to, for a community to decide what to do as a final service. We need to stop somewhere. We have to find the right boundary somewhere, and then show maybe one or two end user products, but then we can't have that done massively across. The most important part for me is to let the data open and free from multi-model and even the models themselves in this data lake, which you heard, and then have instruct people how to use it properly and what the different tools are, what they are, and then the rest will be built by many users, many other users. So my reference point for global cost and for cost predict is still to arrive to test with intermediate users and contacting, engaging the final users, but they are not going to be, you know, the one that will constantly be in touch with me. I hope there will be an intermediate user in each country that will do this work. Also a private user that will do this work, because we know government can't do everything. And so we really have to engage in a public-private discussion on this.
So I was just wondering how well we here as a community have thought about engaging with the concepts of how we value coastal ocean assets, value meaning monetary dollar pound sign values on the ecosystem, on the services, the value in terms of well-being and health and things we can't put pound signs on necessarily. And often coastal managers will use things like natural capital accounting and frameworks and risk registers that try and integrate economic values, social values, environmental values, and they make management decisions about the marine environment, aiming at sort of more resilient coastal communities based on those things.
my perception is that we're really strong on the environmental side here. But maybe we need to think about how we integrate a little bit better with the social sciences, environmental economists. I'm just throwing that out there as something to think about.
Another question? Yeah. Christina, try to speak now.
Yes, okay. Can you hear me now or?
Yeah, now very well.
Okay, perfect. Sorry about that. I'm really very thrilled to be here in this meeting. I'm learning a lot, and I'm really impressed about how the entire oceanographic community comes together for different purposes. And I work for the U.S. Coast Guard, and we use models to search for and find people at lost at sea. I don't know if you can hear me okay. There is a...
Very well.
Okay. Okay, perfect. So we use all the models available around the world to do our drift modeling. And I'm very interested in the relocatable models that you've been talking about, and that is one of the main focuses of your group. And so that's a very important thing for us. There are many regions where in bays or that we don't have models, so we cannot find the people. Also in the middle of the Pacific, in small islands or atolls, it's very, very difficult to reproduce the dynamics in those areas with low resolution models. So I'm really interested in hearing more about that, and you know, how you see the future, either fixed relocatable models in specific areas, or models that can be set up on the fly to predict the currents and the wind.
Thank you, Christina. Well, of course, the future, what I see at least, is a combination. No? So in selected area, for sure, we will be able, especially in the national waters of many states, we will be able to have high resolution systems. And I think CostPredict will contribute. But on the other side, in other global south or what is not coastal but is open ocean for you, then there is the need of the relocatable modeling system. So we have different initiatives within CostPredict, but also as European project like the Edito Model Lab that will implement it in the next 2 years. So I think it's really a good opportunity today to interact with you, and of course open to interact with other users that need this, like Navy or other Coast Guard. And I think it will happen. Also, what is interesting is to try to understand how to integrate the observing system in the relocatable, because I mean, doing the model, it will be a component, but relocate and launch drifter. So maybe we can also consider to have a joint experiment or joint test site in unforeseen reasons, in unforeseen regions. I mean, in new regions. So do test case together, I think is also another opportunity. But I'm sure we will solve it in few years.
Okay. Yeah, it's really exciting, cutting edge what you're doing. I know there are lots of challenges, but it's very important. So I'm really happy to be here.
Yeah, thank you. We are also very happy that you're joining us. And there was Aldo.
You know, just another brief comment, because indeed the discussion was becoming and is very interesting, because here we are trying to organize our journey, isn't it? But on the other hand, let's remember that the decade is already quarter gone. 25% is already gone. And therefore, we do not have much time if we want to achieve within the ocean decade umbrella. Having said that, there are still a lot of things where we need to do more research because we're not prepared yet. But on the other hand, there are other things like storm surge modeling and biogeochemical modeling where we can already start offering things. And I think that in this roadmap that we want to plan, I think it would be good that we, first of all, divide the research efforts. Of course, CoastPredict will need to have a research component which will continue to advance what we already know to the next stage, to the next level. But on the other hand, we can prioritize some things that we are ready to do, and therefore go into the also application. There are some things in which we are ready to apply and therefore ready to give to the users. We need not promise the users everything, but we can promise them to give them the standard and several good applications. And I think that we should start from there. And also with the mentality that we need to do this together, because we started from the fragmentation point of view, and therefore how to do these things together. This is something that we need to discuss further. But to give an example, as we were speaking also during the coffee break, taking the example of the relocatable biogeochemical model, relocatable doesn't mean that we have to relocate the resources. If we have a relocatable model, it can be run anywhere else and without the need of relocating, that is, having a high-performance computer cluster in every country, in every corner of the Mediterranean. That's not needed. We can have and construct an overarching framework where transnationally we are collaborating. At the national level, we have the groups that have the expertise, and if they do not have yet, we train them to have it. And when we run these systems, we run them on a Bayesian scale, so that every country and every group and every institution that is relevant experience can take part with this method of doing things together, which we have to still define in more detail, but we have to find the ways and means of doing things together. And this reminds me of what we did in MFSPP. This was Nadia's first main important, I guess, Nadia, intervention that you had. But in MSPP, I remember this was the attitude, we were doing things together. We have to repeat it in some way or again here.
Yeah, exactly. But worldwide. So that's even more challenging, but the approach is that. And tomorrow, after the morning session, we will have much more time to exactly define how to work together. Because tomorrow we will define or start to define the sites, and then we will discuss what is the global coastal experiment, global coast